Hey up, welcome back to the Man Cave Workshop, and thank you so much for joining me again. Okay, moving on with this Roberts RFM3. The last video we dismantled it, had a look at it. I was trying to date it. I had a look on the internet and I couldn't find, perhaps there is a site out there where you put the serial number in and it tells you the exact date, but I couldn't find the exact date on it. So what I did, I started looking through YouTube, and I know I've mentioned this guy before, but Radio Cruncher has done an absolutely, I think it's quite a big series on full restoration of these radios. Very good to watch. What I'll do, I'll put a link in the description to it. To what the part that I found pretty interesting in dating stuff. As what he said on his video is, in the older versions, where this IC1 chip is, which I thought I couldn't see it last time because it's hidden underneath that tuning wheel down there. On the older radios, there are two transistors, and this one has a chip. So like I said, I'll put a link in the video to that for you to go and have a look at. Off watching that video, I know that this is the later model. Also, I was reading through the comments in the last video. Thank you very much if you commented, really appreciate them. And there was a chap called Ninja, a guy called Theo, and Nick from P-Tronics had said, with these capacitors, if the radio works fine, I think it was Theo said that these are quite reliable ones, so they said leave them be. So without further ado, what we're going to do, we're going to test it, see if it works. I'm pretty sure it will, because like I say, when I used it years ago, it worked fine. Since then it's been in really good storage conditions. So unless anything's gone to sleep over them years, I've got pretty much certainty that it will work. So let's connect the speaker. Let's give it 9 volts. Let's see if this set is an on-off button there. Let's switch that off. What we on? We're on FM. Switch the power on. It's on a DC power supply limiter. Keep mentioning that because if you do test radios that you're not sure of, it's always best to use it, because if anything goes wrong it will cut out before anything blows on the radio. Right, on. Oh, that's a bit scratchy, that pot, isn't it? The volume pot. But it appears like we've got FM. Sounds quite clear. Apart from that, that's a bit scratchy, that volume pot. We'll have to deal with that. Okay, let's try medium wave. Actually, that seems to be getting better now. I've twiddled it about a bit. Must have been some muck in it.
A couple of years ago, I, in a fit of madness, decided that I would try to be a woman that runs, and set off along to my local seafront. I'm
listening because I can't forget which one of the guys said, if it sounds clear, the caps are probably okay, and it does sound pretty clear. Now, long wave, or LF as in this case, I'll be lucky to get radio 4. Definitely got radio noise. Just picking up that station there, you can tell it's working. It's picking up all sorts of interference in here. Let's go back there. Yeah, I think this radio's fine that way. So let's get it all unplugged and move on. Now then, moving on, what I do want to do with this radio, and it's something I've not done before on a set, is one of the biggest killers of these radios is they take the DC power supply through this DC jack here, and it states, you remember when I took it to bits, it says it has to be a negative pin. So let's grab the correct power supply. So it's the Roberts PU609, and if you look on here you'll see this little drawing here, and you'll see that it goes to a dot there and it says negative. That means that it's negative pin. It's 9 volts and 300 milliamps current. It means it's negative pin, so this would be fine, no problem at all. Now what can happen is, and I've just dragged out a supply, I don't know if you can see it very well if it focuses. This is obviously this is 12 volts, this would be no good anyway, but you can get 9 volts ones of these, and if you look at that one it says positive pin. So if you plugged this one in, it would send the current completely the wrong way through the circuit, and it's not made to do that, and it would damage components in the radio really badly. So we don't want that to happen. Now I think a lot of modern circuit boards have some sort of protection against that, but I don't think this radio has. So what I'm going to do is I'm going to pause now, and I'm going to drag out a couple of bits to have a look at. Right, I have done some research on this, and I am going to draw myself, a diagram, so I can understand it a little bit more. So let's say we've got the radios here, and it wants positive going in and negative coming out. So let's draw, let's say radio. So there's the positive going in and the negative coming out. So let's do this in red, then we can see it better. So there's your positive going in, like that, and the negative comes out of the set, and all them components inside that set are happy like that. They got no problem, that's how they were made to work. Now what happens is, if somebody put, instead of a negative pin here, a positive one, it would send positive all the way in, and like I say, damage all the components inside this radio, or some of them. So I want to put some sort of protection to stop that, and what I'm going to use is a diode. Again, I'm learning all this, so you'll have to bear with me. And the diode, the way it works as far as I can see, I mean the diode symbol on a circuit board looks like this. It's usually like an arrow and then a line, and on the line on this diode, the line is called a cathode, I think. We'll just put C there, and the arrow is an anode, I think. And what that does, it allows the current just to flow that way. If the current tries to go this way, it blocks it. It won't allow the current to pass. It's like a valve. It'll only let current go through one way. So what I want to do is to stop any positive pin or positive charge going through the negative pin of this. I think I want to put a diode in that way. Let me draw it again. This is, if you know all this, then great. It's more for my benefit of learning what I'm messing about with. So radio, or the load, and we said positive and negative, and I want to put a diode in that way, I think, because all being well, if the radio's working right, the current's going this way, no problem. If somebody put in the wrong pin, say somebody put in positive here basically instead of negative, it should hit this wall or valve of the diode and go open circuit there and stop any current going into the radio and damaging it that way. I think that's how it works. So let's have a look on the circuit diagram here. I've been doing some notes. So I think I need to put the diode there. This is the pin. So on here, it would be that black wire there. Whoop, sorry, I'd knocked the camera then. Yeah, it would be that black wire there. So I think I need to put the diode in here. Now the way this works, it's a three-way switch, jack, DC jack. The way it works is, let's see if we can work out how the way it works. Got the positive on the battery going in here, and that also comes out to this line here. But where's that supply? When you put there's a colour going funny on this camera. Might be, I'm quite close up, aren't I? Don't know if you can see that switch. When you put the jack in, them two come apart, so it disconnects this red wire that's connected to the positive on there, on the battery, and it activates, by doing that, it activates this yellow wire, which is really the positive from the jack input, which goes into the circuit here. So yeah, I think I need to put my diode in here the right way round. So what I'll do now, we'll test the diode actually. Okay, let's test this diode. But it might be dragging on a little bit, this big video, so thanks for staying with it if you've got this far, and putting up with me showing you what I'm learning. So what did we said with this, with diodes, that they have a cathode and an anode, and if we sort of drew it on, it'll let current go through it that way. Can't see, can you? So it's got a cathode and an anode. It's marked like that. So I've dragged out a diode here. It's gonna be tricky. So I think that is the cathode end, and that's the anode side. What I'm going to do, I think you can. This diode is a 1N34A, and I've looked at the specs because I was getting a bit worried that if I put the wrong one in, it wouldn't be able to handle this 9 volt and 300 milliamps. But I've looked at the specs on this particular diode, and it'll handle 65 volts and 500 milliamps, so it should be okay. But I'm going to test it on this PP9 battery to see how it all works. A PP9 battery I had a look at as well gives out between 400 and 600 milliamps. So if it's going to pop, it's going to pop on this. Let's get the meter on. I say that if you're staying with this video so far, thank you. Thanks for watching this far. I don't think my videos usually go on this long. Right. The other thing with a diode as well, what I've read, is that they will drop the voltage a little bit. They do soak up a little bit of the voltage. So let's test that first. So this battery has 9.34 DC volts. That's a good battery, isn't it? Oh, I'm on the positive side, aren't I? So to keep this flowing, I think I put the anode side towards the positive So the valve, well, the diode, should allow the current to flow now, and we should be able to see if it drops it down. What was it? 9.33 something. Let's pop it on. So there you can see it is letting the current and the voltage go through, but it has dropped. I think the radio would still run off around 8 volts anyway, so I think that drop would be okay. I'm just holding it on for a little while to see if this gets hot or anything. It's best to test it out, the radio. Oh no, it's just the same temperature as before. What I want to do now is turn it round to see if it will block everything coming through, as it should do if when it's put into this circuit on the radio. Here we go. And yeah, it appears to be doing its job. Let me hold it on for a while because it's getting reverse current through it now. Let's see if it gets hot now. Just hold it on for a few seconds. We'll soon find out. No, it's absolutely fine. Let's turn it around again just to test that again. So there we go. That way it will let the current through. Turn it round. Let's let this meter calm down a bit. There we go. And it really does block. That's good. It's going to do its job. Okay, let's get it in the radio. I'm just about to put this... I've lost the thing now. Oh, there we go. This diode in. And instead of cutting the wires or anything or messing about with the circuit board, I'm just going to desolder here. And I'm just going to pop it in there. That way it should be nice and neat. And we want the cathode side pointing that way. So I'll get on and do this now. You don't need to see me desolder and solder it on, and we'll show you what it looks like when it's done. So okay, through the magnifying glass so you can see what I can see. Let me set this up right. I've just desoldered that wire there, kept it all clean. I thought I would show this bit so you can see if it focuses. You can see where the cathode side is, which we want going the way I've got it actually. I want it going that way. And I'm just going to pop that through. I'm not going to heat shrink this or anything, because if anybody opens it up, I want them to be able to see that there is a diode in there, just in case it causes any problems in the future. You know, if somebody really goes to town and blows the diode, when I'm long gone and hopefully this radio is still working, somebody will be able to see what's been done. Okay, so let's just solder that in. As always, heat up the work. Camera's totally in my way, makes it awkward for me, but I don't think diodes like too much heat, to be honest. I don't think that jack would appreciate too much heat on it for too long. I'll snip that excess off there. And then we'll just J-clip. Make a J-clip there, just bend it over. So we get a mechanical joint as well. I'm going out of shot here. I'm going to have to move the camera out of the way. I'll show you when it's soldered. So hopefully you can see that. Oh, I forgot to take the excess off that leg there. I think that's the right way round, and it all looks neat and tidy. So that little guy there, hopefully, should protect from any wrong DC adapters being put in. But what we can do now is test it. Right, I've just got the speaker connected back up. We're all off. I've got the let me unplug it so you can see. I've got the correct DC adapter in. So let's plug it in. If I've got this diode the right way round, the radio should work. Let's plug it in. Switch on here. Switch on. Still a bit scratchy that, but there we go. Right, what I'm going to do, I'm not happy with that actually. I'm going to lift it again. Are we focusing? No, I'm going to lift it again. I am going to put some heat shrink on it because it'll just look tidier. I'll just feel better about that. So get on and do that. We'll have a look at that when it's done and move on. So there we go. I just took it off and just put some heat shrink on it. It's still, I've tested it again, obviously it still works, no reason why it shouldn't. It just looks a lot neater that way, doesn't it? Well, okay, there we go. That's the end of this video. So that, as I hope you probably knew in the first place anyway, but if you didn't know and you've learnt along with me, that is how to protect a Roberts RFM3 against reverse polarity destruction. Well, if you stayed to the end of the video, thank you very much. The next one will be the final on this radio, because all we're going to do is, we're going to have a look at flipping over this dial, back of the dial face, and we're going to tighten up this turntable, clean the pots out and put it back together. So yeah, thanks for all the comments, thanks for watching, I hope you've enjoyed it. And I will catch you in the next one. Be good to each other.